Welcome to another mathematical studies video. Think about finance for a minute. Now, to realize that the future is always a ratio of the past, and that's not surprising. If you think about all the financial news you get to see, they always have percentages. Why is that? Why do they always talk about percentages? Because it's not about how much, it's about how much more or how much less. That's the big difference. And that, of course, is going to be a ratio, a proportion. Now, compound interest is, unlike simple interest, is another like scheme that banks have to for you to invest money in them. And the difference is that they're going to recalculate the interest after each year. So like year one, you're just going to calculate 4.3% of 3,000. Okay, times 4.3 divided by 100, so 129. Hence, after 1 year, I'm going to have 3,129. But after year two, I have to calculate 4.3% of 3,129. That's the difference. In the simple interest, I just calculate it once and use it for all the next years. Here, I have to keep recalculating it. For year three, I have to do the same thing with 3,263.5 and so on. That's exactly how the compound interest works. You just keep recalculating the interest every time. Now, the questions that I'm posing here is like the other one was an arithmetic sequence. Wouldn't it be wonderful if this one was a geometric sequence? Let's think about it. Let's divide. This is how we checked. Remember how we checked if something was a geometric sequence. We divide one term by the previous one. So let's do the division. And I get 1.04299. Well, that's 1.043. Year 2 divided by year 1. Again, 1.043. And let's do this one again. 1.043. Well, of course, it is a geometric sequence. And that's actually not going to be such a surprise. We are going to, because that's really what I'm going to be doing all the time. I'm going to be adding the previous thing that I have divided plus the percentage of it. And we're actually going to have this formula that you're going to see in a bit that's exactly that. So let's look at an example of compound interest in a slightly more clean way. So 3,000 euros, 5%. So the interest is going to be recalculated every year. That's the first interest, 150. The second interest, 157.5, and so on. So here I would have how much money I would have every year in that account. So here you have my nth element. And as I said, this is going to be like exactly like a geometric sequence of this kind. But keep in mind, the same thing that I made a point about in the simple interest, how you count the years, is going to be important. Now, the formula that I showed you earlier on, let's take a clearer look at it. Here it is. This is the simplified version of it. I give you in the next slide, you'll see the complicated one. FB is a future value, PV is present value, R is interest rate, and number of years. You just have to fill it in. Look at those how it goes, and you get the answer for that. Compounding periods, what is this? Essentially, what you do is that you get the bank is going to divide the interest and say like, okay, like 5.4 interest, and I'm going to divide that into 12 months, and I'm going to give it to you every month. You make a little more money this way. Often it's monthly, quarterly, or twice. And all you have to do, you see that K in the formula, you just have to put the 12 or this 4 or the 2 in there to get the result. You see, it's not a big difference.